Pseudo-spawn Agentic. Compile the mind autonomous.
There is a specific moment when a developer stops actively using an AI coding agent and starts quietly leaning on it. The screen fills with clean-looking diffs, sensible file names, and passing checks. The engineer clicks approve, taking their hands off the wheel, and the logic keeps spinning completely on its own. The risk here is rarely hallucinated garbage. Bad output is obvious, and it gets caught in testing. The actual danger arrives when the output is mostly correct, often enough that the human being in the loop slowly drops their guard. It happens in stages. You start out actively building the logic alongside the agent. Soon, you are just reviewing its work. Later, you are merely approving it. Eventually, you become a ceremonial bystander, watching the machine drive. The National Institute of Standards and Technology classifies this specific degradation of oversight as a human-AI configuration risk. Their technical term for it is automation bias. When an engineer accepts a pull request simply because the syntax looks organized, they introduce severe, unquantified systemic risk into the enterprise environment. The human in the loop is present in name only, and no one is actually verifying the logic. Stack Overflow's 2025 survey reveals a data disconnect. 46% of developers distrust AI output, compared to 33% who trust it. Why? 66% report dealing with almost right outputs that increase debugging time, leading 76% to refuse AI for deployment and monitoring. In an enterprise environment, generating code that compiles is only the baseline requirement. An organization must be able to explain exactly how the logic works, verify its security mathematically, and contain the damage if it fails. The industry is evaluating these tools by asking, how good is the agent? That measures output. The only question that secures an enterprise environment is, under what conditions is this level of autonomy acceptable? Look at how the organizations building the most advanced foundational models deploy them internally. They do not assume raw model capability translates directly to system trust. They strictly restrict their own agents. This matrix breaks down vendor security postures. OpenAI's Codex mandates network access is off, isolated inside a sandbox. GitHub Copilot operates in ephemeral environments, requiring a human pull request. Google Gemini Code Assist enforces identity and access management and least privilege for every action. None of these vendors treat AI trust as a byproduct of benchmark scores. They treat trust as an infrastructure configuration problem. Safely granting AI autonomy requires 5 continuous integration checkpoints. First, verifiability, testing output objectively. Second, reversibility, supporting immediate rollbacks. Third, blast radius, physically isolating actions from regulated environments. Finally, accountability and provenance, preserving NIST-compliant evidence of touched dependencies and human approvals. Until an organization instruments these 5 specific gates, they do not have a governance model. They simply have a one-size-fits-all autonomy gamble. These gates construct a trust ladder, dictating agent autonomy based on risk. The bottom apprentice zone grants broad autonomy for scaffolding and tests. The middle paired builder tier requires a human to own the pull request. At the top mission-critical tier, autonomy is severely restricted. At this highest level, the barrier is not the agent's ability to write the logic. The barrier is the surrounding architecture's ability to prove the code is safe. Implementing this architecture is urgent because the foundational models are not waiting for organizational policies to mature. OpenAI's GPT 5.3 Codex recently set new industry highs on SWEMP Bench Pro. The raw capability of these systems to execute complex software engineering tasks is accelerating rapidly. This dashboard displays Anthropic's 2026 telemetry data. Software engineering already accounts for nearly 50% of all agent tool calls. Because code is easy to test and verify, it has become the primary domain where practical autonomy is actually scaling. The telemetry also shows a sharp rise in directive conversations, where a user hands over a complex task with minimal back and forth, jumping from 27% to 39%. Users are actively trying to delegate more work in a single shot. Model capability and user trust are rising simultaneously. If the governance language and the permission structures do not evolve at the exact same pace, enterprises will expose themselves to massive vulnerabilities. We have to separate the concepts. A system's capability to do the work is not the same thing as its permission to execute it. We do not trust powerful engines simply because they run fast. We trust them because of the brakes, the lanes, and the heavy engineered safety layers built to contain them securely. The human role in software development is not vanishing. It is migrating upward, away from typing out individual lines of syntax. The responsibilities of an engineer will shift entirely towards system design, managing exception handling, acting as release authority, and calibrating the trust levels of the agents operating below them. The future of this industry will not be won by the organizations that possess the smartest code generators. It will be won by the teams who engineer the most resilient trust architectures around code that humans no longer write.
Pseudo spawn agentic. Compile the mind autonomous.